Kia ora koutou. This is a video from the 2014 Pure 3 paper, and it's a factor theorem question. If you're watching this and you're not doing Cambridge A-level, but you are doing level 3 complex numbers, I think it's quite a good excellence question for that standard as well. So have a look and see if it makes sense. There's nothing in here that is not covered in the level 3 curriculum. So it's a kind of weird setup. We're told that we've got a polynomial f of x, and it's of this form, x minus 2 squared g of x, where g of x is another polynomial. And we have to show that x minus 2 is a factor of f dash of x. So that sounds really, really hard. But if you're doing A-level, you can see it's only worth 2 marks, so it really can't be that bad. And all we have to use in here is to recognise that f of x is a product. So we're going to use the product rule to get f dash of x. That's the first part of the question. Now the second part of the question is this. We've got a polynomial, this thing, x to the power of 5, which may make your heart sink, and we've given a and b are constants, but we don't know what they are. But we're told that this polynomial has a factor of x minus 2 squared. And then we're given a big hint that using the factor theorem and what we found out in part 1, find the values of a and b. So this is one of those questions where if you see what to do, it's actually really, really straightforward. But if you don't, you can go down a very bad wild goose chase. So let's start with part A. We've got f of x, and it's got this form, right? So it's a product. It's x minus 2 squared times g of x. So what is the derivative going to be? Well, you can use your u and your v if you want to, but if you're watching this, you probably don't have to. It's going to be the first function times the derivative of the second. Now all we know is that that will be g dash of x, plus the second function, g of x, times the derivative of the first, which is 2 times x minus 2 by the chain rule. Now we have to show that x minus 2 is a factor, and you can see it sitting in here. You've got x minus 2 squared here in the first term, and you've got x minus 2 in the second. So we're going to factorise it and get this. So we get x minus 2 into this. X minus 2 g dash of x plus 2 g of x. Okay, so that means that we can say that x minus 2 is a factor of f dash of x. Right, so that's the first bit done. Now let's go back up. This polynomial has got a factor of x minus 2 squared. So what does that mean? Well, that means that x minus 2 is going to be a factor of its derivative. So I've written this up using some nice notation. You can probably get away with a little bit less than what I've done here. But I'm going to start by defining p of x to be this thing that we've got. We've got x to the power of 5 plus ax to the 4 plus 3x cubed plus bx squared plus a. And we know that x minus 2 squared is a factor, so we can write this like that. But we can also say that x minus 2 is a factor of the derivative. Okay, now what can I do now? Well, we've got p of x. So by the factor theorem, if x minus 2 squared is a factor, we must also have x minus 2 as a factor. Right, it's just like when you're learning your tables. If 8 is a factor of a number, then we know that 2 is a factor of that number. Same thing here, just a little bit harder. So if x minus 2 is a factor, by the factor theorem, we have this, p of 2 is equal to 0. And since x minus 2 is a factor of the derivative, we know that p dash of 2 is equal to 0. And that's the key to the whole question. Once you've got that insight, all you've got to do is work those two things out. You're going to have two simultaneous equations in two unknowns, a and b, and you're going to solve for them now. So that's what I'm going to do. You might want to pause the video here and just try that yourselves. Okay, so here's the polynomial. That's p of x. you can differentiate it. And then you're going to find p of 2 and p dash of 2. So let's do that. So we've got p of x is, what is it? X to the 5 plus ax to the 4 plus 3x cubed plus bx squared plus a. Substituting in 2 gives me 32 plus 16a plus 3/8 24 plus 4b plus a, and that equals 0. So let's clean that one up first before we go any further. We get 56 plus 17a plus 4b equals 0. So that's equation 1. Now, what's p dash of x? I've just realised why this question probably won't come up in a level 3 paper. It's because it mixes up differentiation and complex numbers in algebra, which is a shame because it is quite a nice question. So there's 2bx. So that's p dash of x. And now we know that p dash of 2 is equal to 0. So 5 times 16, am I doing this right? Yep, 5 times 16 is 80, plus 4 times 8, so 32a, plus 9 fours are 36, plus 4b is equal to 0. Now let's clean that up. And this is what we get here. So we've got 80 plus 32a plus, no, hang on, that's not right. It's not 80, it's 116. 116 plus 32a plus 4b is equal to 0. Okay, let's line them up and see what we get. Well, we've got 17a plus 4b plus 56 equals 0. 32a plus 4b plus 116 equals 0. So very easy to do elimination on this. We'll do equation 2 minus equation 1, and we get 15a plus 60 equals 0. So a is equal to negative 4. We can take that and we can chuck it into, let's see, we'll put it into the first one. What does that give me? Negative 68 plus 4b plus 56 equals 0. 4b is equal to 12. Sorry about the background noise. And b is equal to 3. Right, now let's go back and see if we had to do anything else with this question. But I think that's it. We've got our a and our b, negative 4 and negative 3. Yep, that is all we had to do, right? So there you go. Quite a cool problem. I haven't seen one like that before. Make sure that you understand all of the little steps thoroughly and yell out if you don't yet.